free body diagram. So for free body diagram is that in a system consists of many objects, we can separate individual objects to see all the forces that is acting and what is the net acceleration or net force acting on the body by separating out from the system. Okay, here, so if you have many, okay, it will get clear gradually. Few things you need to know. That tension, this is the most important thing you must know, that tension from any body will always be directed out from the body. Always tension, force we will see. Force will be, it's a push or pull, whatever, but when it comes to tension will be always directed out. Got it? Remember that.
Yes.
So let's see some example for, then you are going to understand with a free body diagram. We will go step by step. First we will go for the connected bodies. Free body diagram of connected bodies. That is, what is the motion involved in connected bodies. Okay, first one. So let's see. Pulley system. So in the pulley system is that I have a pulley here. This is a pulley, frictionless pulley. I hope everyone know what is a pulley, right?
Yes, sir.
Let's see what is the mechanical advantage you get from a pulley system. So this is the one block which is hanging from a massless string. On both of the string is massless, right? And here is another object, correct? So what are we going to find out? So this is M1, this is M2. So the weight is acting downward, M1G, M2G, sorry, and this is here is M1 into G. We need to know tension. This is also, this is the tension T. Now here, tell me, if this is T, this should also be T, right? Now,
So why?
because that's the tension on the string now. Whichever will be the tension, it will get the same thing or not. Okay?
Yes.
Now let's say M1 is greater than M. That means this is greater. If this is greater means what? The whole system is coming down like this. Acceleration, right? And this one is going up with an acceleration. So what are you going to do the free body diagram? So FBD, free body diagram of M1. First let us go for the M2. So in case of M2, what you see, it is T minus, you are going up. So which one is heavy compared to the weight? Definitely T is heavy.
Yes.
Compared to that means which is equal to M2 into A. This is a common acceleration. Remember, this common acceleration is what we are going to find out. And that tension is a common tension. What are you going to find out? For free body diagram of now, M1. What do you think will be for M1? For M1 it would be, can you guess?
M1G minus T.
Why M1G? Because it is falling down. That means that weight must be greater compared to tension. Right? Should be equal to then how much? M2 into A. Right? Then
Yes, sir.
divide them. Can we divide, or we can separate? Whatever way you want, we can do it. We can take the value of tension from here and we can plug it in here. That also will do. So for example, from
Sir,
equation,
A will be the same for both bodies.
huh?
Sir, A will be same for both bodies.
A will be same for both the body. Both the bodies, the A will be same. So we can take the A from here, or better we can take the tension out first. We'll substitute it here. So T will be, so this is equation 1, this is equation 2. So what can I do here now? I can plug in the value of T here. So it would be M1G minus M2G plus M2A is equal to M2A, right? So what do we get here? M1G minus M2G minus M2A is equal to M2A, right?
So what we are trying to find?
You will see. Then what can I do? I can take here M1 minus M2 g is equal to, what will I get here? I think I have done some mistake here or what. This is m2. First one is, oh, this is m1, no? Oh no, this is m2 only. So this is
In the second
m2g plus
equation, m1g minus t.
m1g minus m2. This is m1, no? This is m1. Why I have
Yes.
written here m2? This is m1. This is m1. This is m1. So this is m1 means I get here m1 plus m2 into a. So what is our acceleration? Our acceleration would be m1 minus m2 by m1 plus m2 into g. This is the common acceleration of the object. So imagine I gave you 2 kg and 3 kg mass. You can easily find out what is the common acceleration, right?
Yes.
What about the tension now? What about the tension? How can we find out the tension? To find the tension, divide them. Divide them. Divide equation 1 by 2 or 2 by 1, doesn't matter. You divide them. So if I divide T minus M2 G divided by M1G minus T, I will get here M2A by M1 into A. So A is removed. Clear? So now what to do? So T minus M2G is equal to M2 by M1 into M1G minus T. So T minus M2G will give me M1 into M2. Sorry, M1 get cancelled here. It would be M2G, right? M2G minus M2 into M2T by M1. Let it be there. So let me bring this side. We need to separate them now. So T plus M2 by M1 T is equal to M2. Is this M2 or M1? Again I am doing that mistake. I am writing so badly. This is M1. Oh, this is M1. Oh no, M2, no? M2. This is M2. M2. Yeah, it would be 2. It would be 2 M1 M2 G divided by, no, not divided. So this much only. Now what to do now? Then I can take T common out. What will I get? If I take T common out, I'll get here 1 plus M2 by M1 equal to 2 M1 M2 G. Little manipulation now. So T M1 plus M2 divided by M1 is equal to 2 any mistake here? I think I have done one mistake here. Okay, this would be 2 M2G. No M1 here. No M1 here. 2 M2G. So now we get our value. T would be equals to, this is M2G. So that gives me 2 M1 into M2G by M1 plus M2. That's it. This is the tension. Okay? Clear? Clear?
Yes, sir.
So this is the tension. Let us give an example. Let me give you an example. You try this and give me the answer. I'm giving you a pulley system. I'm giving you a pulley system here. Here I have 2 kg. This is T. And here I have a 3 kg. Find A and T. Do it fast.
Acceleration is approximately minus 2 meter per second square.
Acceleration is
So minus 2 meter per second square.
minus
2 meter per second square.
okay. And what about tension? Done.
Sequence of the time. So tension is 20.
Tension is
So 20 Newton.
20 Newton. What about Avi?
Sir, I got the acceleration 1 by 5 meter per second and the tension was 24. So I took G as 10.
Okay, take G as 10. Okay. Now I think I will do like this. Before I come to, I will teach you very advanced free body diagrams. So it would be necessary for me to do with you friction. Okay? Because I will treat both, one with friction and one without friction. But you don't know anything about friction yet. Okay? So I just changed my mind. I will first do friction with you. Okay? Then the last topic will be our free body diagram with all kind of connected bodies, with friction, without friction, we will treat. Okay?
Yes.
Because
Yes, sir.
because or else it would be a double work. Understand?
Yes, sir.
So let me end this and come to friction. What is friction? So I'll come back to this. So let's see what is friction. So friction, as you know, what do you think? It is the opposition offered to the opposition offered by what? Opposition. It is the opposition, or you can say like this. Let me write the friction like this. Whenever a body moves over, whenever one body moves over a surface, a force comes into play which resists the motion, which resists the motion of the body, and is in a direction opposite to the direction of motion. This force is called force of friction. This force is called force of friction. Force of friction. Friction is due to cause of friction. Smooth surfaces in microscopic scale is not smooth, not perfectly smooth. There are ups and down on the surface. When one surface move over the other, there is an interlocking of interlocking of two uneven surfaces. Okay, which results in friction. So if I give you can see this is the uneven surface. So if this is a wheel, what will happen to the wheel? They will get interlocked, no? And if I show you in a much more deep way, if I show you in a much more deeper way, you will see that this is one surface, okay, and this is another surface. So they will get what? They are getting locked.
Interlocked.
So here is the case of interlocking. And there we have consequent friction. Right? Now, frictional force. How do you write frictional force? So you can see now the frictions can be classified as static friction. May I clean it first?
Yes.
Yes, sir.
Now friction can be classified as number one, static friction and kinetic friction. There is also something called limiting friction. I will come to that. Okay, so we'll first understand what is static friction. Static friction. So, what is static friction? The force of friction that exists between two bodies when they are at rest. Okay, I'll give you an example. So in order to do that example, let me do like this. This is an object and this is a block which has been kept on the surface. Now I will slide. I'll give it a material of, let's say, rubber, or what should I give you? Wood. This is an wooden object which is lying on the surface. Let me give it a friction very large friction value. Okay, now if I try to drag this, okay, before that I need to see all the forces and all. I need to see velocity, momentum, not momentum, forces definitely, and I also need to see friction. It will be shown. Yeah, these things will do. That much will do now. So this is also done. So now let me play the animation. Can you see the normal reaction? This is normal reaction, this is normal reaction. Let me give it a little force. I will give it a very low strength force, not much, around, you can see around 1500 Newton. Okay, let me pull it. You see, I cannot. Can you see the friction force coming?
Yes, sir.
See, it is not moving, right? Come on, it is not moving. I'm trying. So this is the example of static friction. That is, your hand is weak, you cannot drag this. The static friction is very large. But you see, after some time, let me do like this. I think we can be able to plot. I will show you the plot. I'll show you the plot. This is not speed. We can do, we can show the legends. Where was it? So axis clear. I have.
So what are legends?
No.
So what
That is the
are
legends. Legends is x-axis and y-axis. I need to plot it. Wait, I'll show you. X-axis here. We need to plot x-axis. So we will do like this. We will do the frictional force, both of the force. Okay. So we will plot like this. Where is that? Frictional force, magnitude, potential energy. Okay, no problem. I think I have the frictional force not been shown here. Applied force, no? Okay, we'll go for force X and we'll go for let us go for the acceleration, right? Acceleration on the y-axis. So we'll go for, no, not speed, we'll go for acceleration. Okay, let's see what we get. Clear? So if I drag now, okay, it will be giving like this, something like that. Yeah, the curve will be like that only. Sorry, I have given magnitude now. So y-axis should be force along. I have already given that. So y-axis should be y-axis is 0 only. Yeah, it will be 0 only. Anyway, I cannot show you the frictional force is this side. Anyway, leave it. So I don't know, because it is not present. Earlier it is to have, but what else I can plot? I can plot friction and applied force. Applied force so I have given already, and speed. We can first plot speed. No, let us plot speed. This should work. Yeah. To certain extent, it will work. It will work. The notice. Is nothing happening, right?
Yes, sir.
Yes, it's increasing, right? And this will do. It doesn't matter. Speed is there, or else we can plot velocity x. Will do, because I'm in the x-axis only. So look at this case. Nothing happening now. There is this maximum value of static friction, after which the body will start, right? After which the body starts. You see, it's moving now. It is moving now. Don't look at the curve. Don't look at the curve, can be whatever be. Look at this. It is moving now.
Sir.
So that
Yes, sir.
maximum value of limiting friction, that maximum value of static friction after which the body starts rotating is called the limiting friction. Okay? So what do you see? That if a body is at rest, the friction between the two surfaces, what do we call it? FR, we'll call this as what? Static friction. Clear?
Yes, sir.
We call this as a static friction. So here is the normal R, weight mg, this is R, right? Correct or not?
Yes, sir.
So now, what is limiting friction now? Let's see. So you can see, I'll say like this. As long as F, I think you can understand what is F. F is the applied force. S is less than a maximum value of static friction, the block do not move. Okay? The block will not move. Understand?
Yes, sir.
As it
Yes,
do not move, that means what? How will you define limiting friction then? So the maximum value of static friction, the maximum value of static friction, which comes into play the maximum value of static friction, after which the body, or not after which, from which the body starts to slide, that is comes into motion, is called limiting friction. Clear? It's called what? Limiting friction. So if we plot a graph now between static friction, we'll come to very soon to come to kinetic friction. Also, let me write kinetic friction also. Now, so this is this is called limiting friction. Now, what is limiting friction then? So limiting friction, maximum friction is directly proportional to R. So F is equals to mu S, static friction, into R, where R is called, or mu S is called, the coefficient of no, not just friction, coefficient of static friction.
Okay.
Coefficient of static friction. Okay? Clear?
Yes, sir.
If we plot a curve, okay, curve, I'll come to that. May I clean this after this? May I clean it? Okay. So wait, before that, one more thing. So what do you think will be the unit of mu? Mu S, you see, F by R. What do you think its unit would be?
So unitless.
Dimensionless. Mu S is just a ratio. Okay, dimensionless, no unit. Now let us come to kinetic friction. Kinetic friction. When the body starts rolling, when the body comes into motion, when the body, after overcoming the limiting friction, comes into motion, then the force of friction that exists between the two surfaces is called kinetic friction. Is called kinetic friction. Again, kinetic friction can also be written as Fk will be equals to mu k into R, where mu k is coefficient of static kinetic friction. For coefficient of kinetic friction. Now, if we compare, which friction do you think is more large? Definitely mu static. Mu static will be mu k, that is Fk. Kinetic friction is less than Fk limiting, F static max, which is nothing but the limiting friction. Okay? So you can write mu k is less than mu s. Remember it. Coefficient of kinetic friction is less than coefficient of static friction. Clear? So if I plot the curve, of static friction by force, applied force, and this is static friction, I will see that the force gradually increases. Okay, now here one thing we can do, I can make, so this is this one will be mg, no, so this would be, I can make this is friction, we can make this as mu r, no, mu into r, normal reaction. Normal reaction was not there, I cannot plot this there. So the graph will be like this, it reaches the maximum value, then start decreasing, and then it becomes a constant. This is, can you guess what is this? This is the maximum value of static friction, which is the limiting friction. And this is, from here, you can see, this is the static friction. This is static friction. This one is kinetic friction. Okay?
Okay.
This is kinetic friction. This is the maximum value, is the maximum value of limiting friction. Clear?
Yes, sir.
Now let us see. Now let us see different thing. There is something called angle of repose and angle of friction. Let us see what is angle of friction. So what is angle of friction? I keep a box here. I keep a block here. Different forces acting will be, one will be definitely the weight mg, and there is also the normal reaction r, right? And there is also static friction, and there is also applied force. Clear?
Yes, sir.
So now, what do you think? So let's say, so this is normal, this is applied force. So this is the case when the body is not moving. Okay, we have taken this Fs. When the body is not in motion, not in motion means Fs is heavy. So even if you are pulling it, the resultant of these two forces is somewhere this side. So center result of these two forces, because when resultant will be this side means what? F is heavy and the body will start moving. Correct? So this
So
angle
can you
is,
repeat?
it is, as the body is not in motion, it means the resultant of R and Fs is along the friction side. Right or not?
Yes, sir.
And the body is not in motion. So this is the resultant force. This is the resultant. So as this is resultant means what can I write here? This resultant, so this is theta. Why we are taking this theta? Because from surface to I cannot take. Surface will be an uneven surface, but this normal will be always perpendicular to the surface. So I have to take this as theta. This angle theta is called the angle of friction. Okay? The angle theta is called the angle of friction. I hope you understand why it is on the left side, why not on the right side. It will soon change because the body is not in motion, that's why it is in the left hand side. Once the body is in motion, once it is in kinetic motion, kinetic friction, then it has to be opposite to the direction of Fs. Keep that in mind. Clear? You will see that. I will highlight it with the next diagram. So now it will be what? So that means tan theta will be, if I take tan theta will be perpendicular by base. What is perpendicular? F of s by r, which is nothing but mu, static friction. That means tan theta gives me mu s. What? Static friction. Be careful. So the coefficient of static friction is equal to static friction is equal to what? Tan of
So tan
is equal to tan of angle of friction.
angle of friction.
Clear? So one thing to highlight from here, one thing to remember here, you cannot ever forget this, that you cannot draw the resultant this side in case of mu s. Okay? Next, angle of repose. What is angle of repose? These are some definition actually we are doing. You see, when you have an inclined plane, when an object is kept at an inclined plane, this is an inclined plane. This angle is called phi. Okay?
Yes, sir.
So now I'll give you an example. Again I'll come back here. I'll delete this. I'll keep this here. Stop the animation. I will keep this here. I will make a and then what I'm going to do, let me rotate it. Let me keep it to this rotation. I will change 12, 13, 14, 15 degree. Okay, I'll keep it here, and this thing has to be supportive or else it will break here. So I will keep one box because gravity will be played here. Okay, now if I play the animation, it will fall. Yeah, fine, no problem. This is not falling. Oh, Control Z. Yeah. Now what I'm going to do, I am going to take this one and keep the box here. I think this is heavy, it may break. Fine, good. Look here. Is it falling?
No, sir.
It's not falling, right? Okay. So then let me do like this. I will extend it a little bit more and I'm going to rotate this also to a little bit more. To how much? 30?
So 30 degrees.
30 point something. This will do, right? So let me keep it here now.
So why does it not fall at less than 30 degrees?
That's the thing. Or else why I'm explaining you. Let's see what happens now. Still it is not falling. Wow. Great, right? Great. At 30 degrees also not falling. Now let me do like this. I will use my hand. I will try to take it up little bit. If I give it a force, it should rotate. Come on, come on, come on, come on, come on. See, it's not falling. Not falling. Not falling. How come? Wow. Wow. What is happening here? Yes. Started falling now. Right? So,
Yes, sir.
so the angle up to which, let me bring this one here because then I can. So the angle up to which the maximum angle up to which the body will not, the minimum angle that the inclined plane makes with the horizontal, so that the body is just about to slide but do not slide. Okay? See, it's not. Oh my god. Great, no? See, because I have given a huge friction for to illustrate
Yes,
this.
sir.
Sir, can we make that body of glass or something else to see?
Yeah, doesn't matter, the friction will see. You see, I'm changing. Yes, 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 yes. Can you see that particular angle? That particular angle at which it is just at the verge of slipping is called our what? It is called the angle of repose. I hope it is clear.
Yes,
So
sir.
this angle will be called as angle of repose. So let us write it. So angle of repose, the minimum angle that an inclined plane makes with the horizontal such that the body is at the edge of slipping or sliding, edge of sliding down, is called angle of repose. So this, I think you can make your definition right, as you understand. Is it or not? So let us understand this. How? Let us see the mechanics behind it now. So if I keep the object here, so what thing is acting? So where is the friction now? Give the direction of friction. Friction is this side, right?
Yes, sir.
At the verge of slipping, this is the applied force.
Yes, sir.
This is the normal reaction R.
Sir, but there did we apply any force?
This is mg. Where?
So component of mg is applied.
No, yes, sorry, I'm very sorry. Actually, sorry. This is mg, right? No, not that is not mg. That is not mg. That is not mg. Sorry, that is not mg. That is something. So
Okay.
mg is here. Mg is here. This is mg. Mg will be always perpendicular, directed towards, directly to the center. This is mg. So I can break it into two components now, and always normal is from where? This is theta.
Yes, sir.
Wait a minute. If this is phi, what do you think this one will be? Now look at this case. This is a very important concept out here. If I put any object, any line here, right? And from here, if I draw any perpendicular, this is the perpendicular. So if this is theta, how much do you think this angle? Okay, I should draw in a big way, guys. So wait, I'll draw it in big so that this is a common thing. You can ask me, sir, very soon I am going to write this as phi, because this and this angle is equal. How is it equal? So let me draw it in big. So in a little, enlarge it a little bit. So this is our normal. From here, this is one normal, this is one normal. Considering that these and these are almost same only. So if this is theta, what do you think this angle will be? This is 90.
Yes, sir.
This is 90 minus theta.
Yes, sir.
That means this complete angle is 90 minus, because this and this is same, right? Parallel only. Now 90 minus theta. So if this is 90 minus theta, what do you think? Where is my gone? Wait.
Theta. So the other side.
This is. So I can write this as what?
So 5.
Phi only. Clear? May clean it properly.
Yes,
So
sir.
bad looking. So then I can write this as this is weight mg, this is theta, which I'm, let me denote it as phi. Here is the components, and here is the another component. This is the normal reaction R. This angle is theta, so this would be mg cos theta. This is mg sin theta. Remember, resolution of vector, we are breaking mg into two components, mg cos theta and mg sin theta. And this is my friction. This is the friction here. What friction? F static. Correct? F static.
Yes, sir.
So now F static, so can I write using free body diagram? Using FBD, what can I write? Fs will be equals to mg sin theta, but Fs is what? Mu s r mg sin theta, but what is r? R is equal to mg cos theta, so mu s equals to what?
So mg sin theta by mg cos theta.
So it should be mg cos theta is equal to mg sin theta. Deduct them and I get here mu s is equal to tan theta, right? But mu s is also, this is tan theta, right? Correct?
Yes, sir.
Which is nothing but equal to tan phi.
Yes, sir.
So that means what? What can I say? Actually, you should write this as phi only. You should write this as phi. Please write this as phi and do. Okay? Write this as phi and then you change it to this. Or else you do like this also, no problem. So mu s equals to, so what can you say? Theta is equals to phi. So angle of friction is equals to angle of repose. Clear?
Yes, sir.
In important proof, if your physics teacher is setting up the questions properly, they should be asking all this to prove. Clear?
Yes, sir.
Now let us do some numerical on this. May I clean it?
Yes, sir.
Sir,
Yes.
Sir, what is meant by that static friction is self-adjusting?
What did you see in the picture? What did you see in the animation? Was it balancing itself or not?
Yes, sir.
It keeps balancing as long as it can hold on to the body. Okay? As soon as if the applied force become too large, then what will happen? The body will come into motion. The static friction can convert into kinetic friction. Friction automatically reduces, right?
Yes, sir.
Now, okay, a question for you to try out. Draw the picture and do. A block of 2 kg mass is placed on an horizontal surface of coefficient of friction, static friction, mu s is equals to 0.2. Clear? Find the force of static friction. Draw the picture and tell me. Take G equals to 10. In the exam, please follow G equals to 9.8.
So 4 Newton.
What is your answer?
So 4 Newton.
Yes, sir. 4 Newton.
Done?
Yes, sir.
Yes, sir.
Next question. A block of mass 2 kg is placed on a floor the coefficient of static friction, I'm just writing mu s, is equal to 0.4. A force of friction 2.5 Newton is applied on the block. Calculate friction between the block and the floor. Calculate friction between the block and the floor. This is the picture I am giving you. That means this is, you are applying a force of 2.5 Newton.
So the friction force is 2.5 Newton.
Yes. The force of friction. Now there is a twist in this. And does the block move?
No, sir.
It should not move.
Why?
So because
Sir, because the
force
friction
applied
force
and the
is-
force of friction both are same, so net force is
How can
0.
this be same? They are not same.
So they are different, but friction force is self-adjusting, so it balances the force applied.
So you see here, no, you see, what is Fs? Mu s into R. Mu s is 0.4.
0.
So,
R is 2 into 10. So 4 to is 8, approximately 8 Newton.
yes, sir.
So force of friction is 8 Newton. Force of friction is much larger than applied force. So body never moves, right or not? This is the applied force. This is the another way of saying, because I just want to move it, so I am applying a force to exit the, to just counter the friction, but that force is less. Now next question, may clean it. It is on kinetic friction. So you know kinetic friction will be same thing only. It would be mu k into r, right?
Yes, sir.
So this is a car. This is a car which is initially at rest. A car initially at rest. A car initially at rest starts moving. Okay, if the, I'm just writing mu k is between the wheel and the road is 0.5, find the minimum distance in which the car achieves 72 km/h speed. Take G equals to 10. I am waiting. Do it.
So what's the mass of the car?
Not being provided. Do you even need the mass of? Here you have to use the free body diagram I'm giving you. So this is Fk,
Yes, sir.
this is F equals to mass into
Yes.
acceleration, right? Who will
Yes, sir.
provide you the, and it's the interesting thing I have told you earlier, MA would be equals to Fk, okay, should be equals to mg, should be equals to mu k mg, mu k mg. So now mu k will be equals to how much? A by g. Very important thing. You see, you start the car, put it in the neutral, will the car move? The car will not move, because that is the motion of the function of the engine is to provide the internal force. It is never an external force. The external force is provided by the wheels, right? Now I will give you a very good example of idiotry, I will say idiot, foolishness of many Shillong peoples. You will see there is a fancy thing, not only Shillong people, all over India people, there is a fashion here to modify their wheels, car wheels. Have you seen?
Yes.
Many people have done that without knowing the basic science involved with. Correct? Maybe few of them know, maybe all of them do not know. They make their wheels thick. Why?
Yes, sir.
They will make the wheels thick. As they make till their turning radius also decreases. Remember that the wheels will not take full turn what they are designed to be. Right? Now, when they make it thick, what happens? They get more drag or more force. Understand?
Yes.
But it has a very dangerous effect. Very dangerous effect, because Newton's third law, the whole, the the force which the wheels provide, the same force that has to be bared by the chassis of the body. Are you getting my point?
So can you repeat, please?
So the force which the external thick four wheels provide to a vehicle, its chassis should be strong, means internal structure should be strong enough to take that force, or else
Yes, sir.
when you drive that little at high speed, it will be shaking.
Yes, sir.
If you have experienced that, no doubt, in an inclined plane they are very good, they are very good to take very load, but at high speed they are very dangerous, very dangerous. The chassis, the body, they will be under unbalanced force, effect of unbalanced force, and that can be very, very dangerous. We should not do that. Correct?
Yes, sir.
And more,
Yes, sir.
the wheel turning effect of the steering is also more torque. We'll talk about all that later, torque and all, in another chapter. So is it done? There is 2 questions I am giving you from NCERT.
So is the answer 2.5 meters?
How much?
So 2.5 meters.
40 meter.
Oh, sorry. I did the question. So what's the answer?
20 I said, no? 40 meter, 40 meter. In your NCERT there are 2 questions. Please take this as a homework for next class.
Yes, sir.
Ready?
Yes, sir.
You'll see there are 2 questions in NCERT. One is regarding the trolley. A trolley is on the table, which is under the pulley action. Or we can do that later. Leave it. Don't do now. I take one question. After I finish it, I will do that question. Take this question. A bullet of mass 0.01 kg is fired horizontally into a 4 kg wooden block. 4 kg wooden block at rest. The coefficient of friction between the block and surface is 0.25. The bullet gets embedded. The bullet gets embedded with the block and the combination moves 20 meter before coming to rest. With what speed the bullet hit the wooden block. Homework.